Okay, so during the break, with Ian Wright's help and Tony's help, we kind of just highlighted a couple of the key discussion items, and then what I thought is I'd open it up to any actions that people saw, that people think that we could pursue, both from APR and NPL perspective, but also just from a community perspective. So just relatively high level. Obviously, there's more detailed notes that we have, but if we just look at some of the presentations, if we had our UK utility experience presentation, there were some questions on why does it appear that there are some of these differences between the U.S. and the UK experiences, mainly in the fact of the tube failures. We talked about maybe potential for an action there from Mr. James' point of view, that looking at just operational data, if that had some sort of effect that was unclear. I think probably the main point that we had taken out of that presentation, though, was currently there's a lot of use for the low chrome ferritic steels of using oxide thickness as a tool for managing life of the components. But that really comes into question: what can you still utilize these techniques with something like a T91 when it delaminates? Can you then actually continue to use this methodology as an approach for maintaining your power plant? You don't have the resolution you need for the stainless steels. So I think those were kind of some of the key takeaways from the discussion and points that were raised. Moving on to the talk from Rudolf Bloom. I think he showed us some of the value in using these test loops and being able to use heat flux. There was one comment that maybe there would be some usefulness in evaluating the morphologies produced in these test loops against the field data. There still seems to be some, at least in some opinions, that there still seems to be some. While these test loops give probably the best pedigree data, some of the best pedigree data we have for kinetics, does it still representing the actual morphologies? Rudolf also raised the point of he currently sees shot peening and fine grain alloys as being equivalent in the EPRI modeling type work without any kind of better data, especially in the shot peen materials. That's generally what we think about. But is there a combined benefit? Should you be perhaps purchasing fine grain and shot peen material as being the best combination? I guess going to one of Barry's comments of do we have alloys that won't exfoliate? Is that the best thing we should be doing?
I would add the composition to that paradigm, because and if you're really going to do a cost-benefit analysis, you need to add in what if you could make it all go away by making sure your chromium and nickel contents were at the high end of the spec. You wouldn't have to worry about whether the grain structure was a certain way or being that done correctly.
I'll fix it. Yeah, I'm not going to. Notice I wasn't the rapporteur for this session.
We know what.
In Dr. Dooley's presentation, there were some key discussion points raised. I think the first one was talking about all the laminations in the scales. Questions on how they actually form mechanistically. Do we even understand that? Or the proposed mechanisms haven't been really validated. If we have these and we say they're related to plant operating condition, what plant operating condition does this actually correlate with? It's not. I think it doesn't appear it's just as simple as starts and stops. I think, is that a valid statement, Barry, from what you've seen? So it's something else. And then there's clear differences on the alloy, and then there may be some influence on when things exfoliate. That's the same comment as before, I guess, that I put on for the morphologies in the boiler test loops. But I think that the main takeaway, of course, is that quantifying the oxide morphology does matter. And although there's a feeling, I guess, that water chemistry isn't an issue, it would be good to have the community have some definitive proof. I think probably as I look at this, one of the challenges is that since we don't have a good match of field and lab data, you can go change water chemistry in the lab test pretty easily, perhaps. But if you can't correlate the field data, you really can't tell how much of an effect you actually relate that to. Tony talked a little bit about these lab discrepancies with the field. I think he clearly showed that in lab experiments you can get pressure to cause some pretty big effects, especially intensification of the oxide, and he also saw some effective heat flux. So it does appear that that there is a need for more work in this area, and probably a big highlight was this coefficient of thermal expansion. The original source of data that most people have been utilizing in the modeling work doesn't look like it's holding up fairly well, and I think that's one of the goals of the breakout session. If everybody came away with a consensus that we need to be using a different CTE, we should be. We shouldn't just keep using old data because it's older. Older doesn't mean better in this case, because we have it right. We should go and try to get the best information. Yeah. This is Dr. Parker's comment on the fact that we keep introducing new alloys in the plant, and we based one of the things we are doing is relatively simplistic steam oxidation lab tests, and we really need to have a test that's going to be more representative. In that same vein, there's been an ISO spec that's being developed, and I guess that was another comment in that area.
It's just air oxidation.
It is just air oxidation right now, though. So, but it's a ways away. Not in steam. What's that? Sorry.
Steam is included in this ISO spec.
Yeah. And how do you generate the steam?
Humidifier. There's a humidifying unit at the end of the furnace. Read the spec.
So I guess for people who need to review that in light of what they're doing. Oops. From the EPRI modeling standpoint, there's still a number of incomplete mechanistic understanding, and I think as we heard, that the criteria for the actual scale exfoliation really needs in the diagram needs to be improved. So hopefully a topic again for one of these breakout sessions is to produce either whether it's a better diagram or more consensus on what the best way to treat the actual exfoliation event. I think that was really the critical comment that came out of that work, that presentation. So that was my really high-level summary. There's obviously some more detailed notes, but what I wanted to open up is, based on some of that discussion, and I know we're going to talk more than Nate, but I mean, what are some of the potential action items that everyone here thinks would be the most beneficial going forward with these kind of questions and discussion that's been raised? I don't know if somebody wants to try to start us out.
We spoke about the flow size, but that needs to be, like you have kinetics for the oxide, the evolution of defects needs to be quantified. So.
From the modeling side, quantification of defect evolution. In other words, we're getting a picture of how scales form, but how about how the defects form in them?
Yeah, you have porosity is forming at the interfaces, and also maybe also distributed inside the scales, and how the interface weakens as a result of that.
But you'd also need some guidance in there as to what parameters you're trying to measure, what parameters you're going to use to calculate the effective or defect size. So there needs to be some protocol in place.
I would find it helpful to know where the sites in the album are coming from.
Won't you tell us?
It's on the list. There's a list.
It's on John's list.
So somebody to do a
That's different. That's how the boys do it.
basically to complete. Be others too. Other things that I didn't capture.
So John,
Yeah.
I think about design as well
Okay.
of the boilers, and I think particularly about two items, and both of them come up today.
Okay.
One is that Paul and I have known each other long enough to know that there's something in what we're saying here that there might possibly be a difference. And so, the boilers in the CGB were designed by GD and CD, their own design department, and they might have different temperature limits for these different materials that actually control the oxidation properties and therefore the exfoliation. So I think that's it's worth looking at, this plant data. And the other item in the design is and so that one would relate to oxidation limit, as I mentioned
Okay, yeah.
in the talk, okay? Because as I mentioned again, it might have just been too quick, but we have an oxidation limit for the outside surfaces of these same tubes.
Right.
And is there something that we can use there for the inside surfaces? Because if we have exfoliation from the inside, we always get it from the outside as well on the same tube, but it's controlled by their oxidation limit. And the other item is the actual design of it. Today was the first time that I had heard from Rudolph that a horizontal surface superheater had a problem. Now, the two cases that he mentioned were a little foolish because they fill the thing with water, and then you would expect it, but I think I heard him say that there wasn't one.
There was
And
one.
the reason that it's important is because I work with utilities putting in new supercritical units, and we've just gone through a whole process in South Africa for 12 new 800 megawatt supercritical units, and we purposely designed them with horizontal surfaces because all the horizontal surfaces in Canada, for instance, have never had a problem, have never had an exfoliation problem. And as far as I know, no horizontal surface.
Maybe I should add there has been substantial problem with huge German 1100 megawatt USC boiler with horizontal.
Well, I don't know anything about it. Was that exfoliation? Was that your
That was exfoliation. That was that particular boiler was originally equipped with the German 17% chrome steel, and that was fully exfoliated, and they have to replace larger amount of superheater and reheater with very high efficiency.
Yeah. Barry, I was going to say I was surprised by the same thing. Most everything that we've seen in Epri has always been in the loop, collecting in the loops. And the horizontal guys they still have problems with erosion and other things, but they don't have problems with
But we actually had it in my boiler tube book, build a horizontal surface because essentially there has not been, as far as I know, anywhere in North America that's had a problem with horizontal surface. And every unit in Canada is horizontal.
But our horizontal designs are a little different. Here they have a big drop,
Yeah,
forming a kind of somewhat similar to a bed. We don't have those.
Exactly.
We have
No, but don't
zigzag.
forget the Esbjerg case. There we just have a plain horizontal one.
Well, that's
So,
good exfoliation as well.
So Rudolph, I don't think we can solve the problem now, but I think this is something that needs
But just to mention it,
Yeah.
it is a problem. We have exfoliation, you have exfoliation, whatever geometry you have.
Correct, exfoliation.
Oh, yeah.
Correct. I agree with that.
we love exfoliation. It keeps us brought us all here. But it's whether it does any damage or not is the important thing.
Yeah, in our units, we have some horizontal units that are stainless steel. We haven't had those issues. Actually, we've been ignoring them.
And it may be the reason why the same thing's happening in the UK. It's worth looking at, I think.
Okay. That's a very good point. And then we talked about one of the other things that was mentioned was the fact that maybe we should get somebody who could type. The other problem we didn't mention was that we should look at the look at from a standpoint of the formation, whether it's the laminations or something else, of getting some more thermocoupling or something on a boiler that then we can get removed tubes at a series of times. So not just a test loop, but actually some actual instrumentation would be the word. So yeah. I mean, perhaps to understand maybe these T23, for example, which is should.
And under instrumentation, why wouldn't we think about some online instrumentation, like acoustic emission or something?
Afford it.
For temperature. Right. Yeah. Samples before failure. Oh, Gordon. Yeah.
In listening to a couple talks, I've heard that there seems to be a difference between, say, T9, T91, T22, T23. I'm just wondering if there's any effect from tungsten, but I haven't heard anybody talking about tungsten. Or, okay. Or the heavy.
Well, we mentioned that as something. I'll put it here, but I think we kind of covered that earlier. It says in similar alloys.
You've got the composition there.
Yeah, I had that earlier. Yeah, so I think we had that earlier. We'll put it there. Well, I suspect the overall list will grow, and maybe we can highlight then at the end of the whole workshop the really key things that we should all be working on as we get lists like this from each of the breakout sessions. So this is just a start, not by anything, something for us to ponder and talk about. And I think now is probably a good time to just back over to Tony to send us all on our way, so we can get started with these hopefully very informative sessions. Yes.
Are you going to distribute those autographs to the session leads?
Yes, I have the exact same. I don't know what that is. Okay. Yes, each of the session leads will have a set of slides like this that they can fill in to help them.
Including the ones you just showed us.
Sure, we can do that. We can have that. That's no problem. All right, Tony.